All right, so number one, sometimes if you're going to find a mistake in a problem, by the way, these problems can be valuable in their own right, but we make sure to do problems like this, especially as we get closer to the regions, because this is a very frequently asked type of question on the Regents exam. All right, so it comes up all the time. On every exam, you can see there will be a question asking you to find the mistake. Sometimes it'll be a multiple choice question, which is weird. It'll say something like, the mistake for this problem is in what step? And then they'll label this one A, that one B, that one C. Or it'll say there's a mistake somewhere related to, this mistake related to step 3. What is the mistake? Is it distributive property? Is it combining like terms? Is it whatever? All right, so sometimes when you see the solution that's written in front of you, the only thing you can really do is go through it step by step and say, is that right? Is that right? Is that right? And and sometimes it's not obvious, but eventually you come across what you think is the correct response. All right, so we're looking at step 1 going into step 2. Does that look like a correct first step? Yes. They subtracted the 4 from both sides, so we're feeling good about that. All right, so that first step is good. Now, we're looking at a trinomial. So when you're dealing with a trinomial, unless there's a GCF, you want to be thinking X chart. All right, so the number that goes on the top in my X chart is what? Negative 12. What's going to go on the bottom? Negative 11. What are my two values on the side? 1 and negative 12. 1 and negative 12. All right, so that's our problem right there. Right. So we can rewrite this. So now we kick over and we start doing it our own way because something went wrong here. Because they came up, we came up with 1 and negative 12. They have a negative 4 and a 1, and maybe that's what would end up being the case when they do their factoring. It just doesn't feel right. So we have 3x squared plus 1x minus 12x. And then the last value was negative 4, so minus 4 equals 0. All right, we're grouping it. On the left, do I have a GCF? X. What's left when I pull it out? 3x plus 1. This marker's killing me. I'm going to use the other side. All right, so I know that 3x plus 1 has to be one of the factors. In order for 3x to become a negative 12x, what does its coefficient have to be? Negative, say it again. Negative 4. All right, so we're looking at x minus 4 and 3x plus 1. All right, so it actually wasn't terribly off from what they said, but they definitely got the signs wrong. All right, so the error happened right here. But that seems to be what botched everything that came after it. All right, so what we can do is just carry out the remainder of the process, set each of those factors equal to 0. When you have a simple linear equation with no coefficient, you just can reverse the sign and be good to go. When you have a coefficient, you might want to take the time to do the extra step. So 3x equals negative 1, making when I divide by 3, x equal to negative 1/3. All right, so these are what our two values should have been. They came up with something completely different. We don't have to worry about the squiggly bracket notation here because they didn't. So, we were just here to critique their work, not do everything that we would have to do in our own class. All right. So we've identified where the mistake happened. Everything else happened, it seems, I'm not noticing anything incorrect. Everything else after that step was correct. Now you got to be careful. On a test, there could be multiple mistakes. All right, so maybe they factored wrong, and then maybe with those incorrect factors, they solved the equations incorrectly, but then came up with the correct answers. All right, so maybe they made offsetting mistakes in this part of the process here and came up with 4 and -1/3. In which case, you might not think they did anything wrong because they're like, well, they got the same answer as I did, so it's fine. Meanwhile, they may have made 3 mistakes in there. All right, so if you're not critically analyzing it, you're running the risk of losing points. All right. Now, number 2 is a question that people traditionally struggle on, which is why it's here. Actually, these 3 problems are the kind of problems that people traditionally struggle on, which is why we're going over them. We've actually done something like this one before. Their first mistake happened in the very first step. What should they have done? Well, actually, sorry, the first step into the second step. But basically,
They should have subtracted.
yeah, they should have subtracted. So things went off the rail right after they wrote the question down. So, like, there's really not much that's right here. All right, so we have x squared. They should have subtracted the 6x. Then after that, what? Factor the x out. Then what?
X equals 0 and x minus 6 equals 0.
X equals 0 and x minus 6 equals 0, which is basically setting each factor equal to 0. All right, so like in terms of an explanation, that's really what we're doing. In the first case, we don't have to do anything. It's already there. In the second case, we add 6 to both sides, and we get x equals 6. All right, so ultimately, they lost a solution. Now, I think you could probably see how dangerous this would be when it comes to multiple choice questions. Because you already know. I mean, I'll even tell you right now, but you already know. There's going to be a question on the test. It's going to have the same format. It's going to be a multiple choice question. One of the choices is going to be x equals 6. Another of the choices is going to be x equals 6 or x equals 0. All right, so it's the one where you could have either of those 2 possibilities, the 0 or the 6. That's the correct answer. But if people go about it the wrong way, they come up with the wrong solution. Even though you got half of the answer, you're still losing all of the credit. All right, and that's, again, I mean, these aren't my rules. Like, I'm the target. I'm the one that's in front of you every day, so it's easy. But this is the Regents exam. This is the Regents board. They're the ones that make these exams, and we have to prepare for them. All right, so it's a graduation requirement. You know, it is what it is. So we just got to kind of get over this hurdle. You got 2 math Regents that you have to take before it's all over, and then once you're done with that, then you don't have to worry about Regents anymore. All right, so this year and next year. So 2 Regents classes, and then after that, it's, you know, local final exams or whatever the teacher wants to do. Like in my calculus class, we do a final project. We don't even do exams. All right, pre-calc, calculus. I don't know what algebra 2 does. I haven't done that in a while, but the higher level classes, we don't even take big exams anymore. You know, it's kind of an archaic process. But anyway, in number 3, the very first step, again, just like the last one, is where it went off the rails. This is where it's incorrect. Yeah, it's not factorable. And I thought I was being a nice guy when I left that big chart paper on the wall, even during the test.
I looked at that.
Did you? That's awesome. That was what it was there for. You know, and I left this up there too. You know, like little notes. If I leave it up there, it's like I didn't forget to take it down, because like the chart paper that said the how to factor a difference of perfect squares, you'll notice that's not up there because I'm not going to give you that. But the things I left up there are the things I don't have a problem with you knowing, so or having access to during the test. A sum of two squares is not factorable. A difference of perfect squares, aka same expression but with a minus sign, that is factorable. But if it has a plus sign in the middle, not factorable. So if you try to factor it, game over. All right? You're not going to get a solution.
I was just gonna not factorable. There's also because you can't like bring the zero to the other side also. Or, like.
Okay, you can't. Well,
Never mind.
that part's okay, but the thing is, really, honestly, the part where it's not factorable is not as important, I guess, as what would happen if you tried to factor it. So I'll just show you really quickly. If I tried to solve this by like linear methods, like what we did back in the first or second unit, we have x squared plus 4x. I'm sorry, equals 4 equals plus 4 equals 0. I can't even talk. So the next step in the process algebraically, the only thing we could do would be to subtract a 4 from both sides, in which case we get x squared equals negative 4. Can you square a number and get a negative value as a result? No. Right? So maybe you don't recognize that. Right? So we try to take the square root to get x alone. Can you take the square root of a negative number?
No.
No. All right? At least not, you won't get a real value. You'll get something that's imaginary. So we have no real roots. You'll learn in Algebra 2 that there are actually roots to this function. They're just not real, right? So they involve numbers that are imaginary, right? So that's not part of this course, so we don't have to worry about it. We just say no solution, and we leave it at that, all right? So what you're going to do is kick on over to